All right, welcome to our video on geometric sequences presented by 3Math Guys. Please subscribe to our YouTube channel and you can visit our website at 3mathguys.com. Okay, so if we've got a sequence of numbers and we want to know is this something we're going to call geometric? A geometric sequence is going to be a sequence where to get from one term to the next term to the next term, that the pattern is that it's multiplying by the same amount over and over and over. So, how do you get from a 4 to a 12? Well, you could go plus 8, but then that pattern doesn't keep going. But you might see it by now. If I go times 3, times 3, times 3, I've got a pattern going. And so this is going to meet our definition of being a geometric sequence because it's multiplying by the same amount. So I can find the next term by just continuing that pattern. So if I take a 108 times 3, I'll get, 324. Okay, so hopefully that makes sense. Now, this amount that it's changing by, we call a common ratio. And the reason we call it a common ratio is because if I take, for example, these two terms and I make a ratio out of those, like if I say 12 over 4, so 12 divided by 4, well, that's going to simplify down to a 3 over 1, which is my common ratio of 3. And it should be the same on all of these. If I take 36 divided by 12, 36 divided by 12, I end up with that simplifying down to a 3, 108 divided by 36, and so on. Now this one was easy to see, but this knowing how this works and why it's called a common ratio can be helpful if the pattern's not quite as easy to see. Okay, so let's look at a couple others. All right, so we've got another sequence here, and we want to look for some kind of pattern here. Is it multiplying by the same amount? And you might notice sometimes it's easier to see even here, like 9 is half of 18. And so some people might notice, well, this is dividing by 2, right? But we want to think of geometric sequences in terms of multiplication, not division. So kind of the equivalent way of saying divided by 2 is to say that this is going times 1/2, times 1/2, and so on, times 1/2. If I go one more time, I could put, negative 9 times 1/2 is negative 4.5, but it's also okay to just keep it as a fraction. So I can say that this is negative 9 divided by 2. Okay, and that would be our next term in the sequence if we follow the pattern. And we can double check that this is the common ratio. I could say, all right, if I want to find my ratio, I'm going to take my negative 36 and I'm going to divide that by the term that came before it, my negative 72. Negative divided by negative becomes a positive, and this simplifies down to 1/2, which is my common ratio. Okay. Now on the next example, can I find a common ratio? This can look a little intimidating at first because all of a sudden I've got some fractions in here. So, how do I go? 12 times what would give me an 8? Well, nothing I can think of off the top of my head. So let's try to be a little more formal about this. Let's say, all right, is there a common ratio? Let's check the way we know common ratios are made. So I'm going to take 8 divided by 12. And I'm going to simplify that down. And that's going to simplify down to 2/3. Okay? So I want to see if that ratio I got is common to all of my terms. So let's try it again with the next two terms. So I can say, well, my 16 over 3 divided by 8. Now, that's not the way most students are used to seeing it, but really this is the same thing as saying 16 over 3 divided by 8, which is just 8 over 1, right? And if you remember your fractions, I can turn this 16 over 3 into a multiplication problem. You multiply by the reciprocal, so by 1 over 8. And then You can reduce it here. This 8 and this 16 become a 2 and a 1, and 2 times 1 is going to be 2, 3 times 1 is going to be 3, and so this 2/3 is going to be the same common ratio that I had here. And if you want to double check a third time, you can to see if it keeps going. Um, and I know most people don't like fractions, but sometimes fractions are the easiest way to find this common ratio. And I'll show you what I mean by that. How do you turn this 3 into a 9? Well, you would go times 3, right, on my denominator. How do I turn a 16 into a 32? Well, I'd have to go times 2. And so if I take what the numerator multiplies by and what the denominator multiplies by, that's another way to find that common ratio of 2/3. And so while initially it seems like, well, I should look for it here, sometimes the fractions are the fastest place to find it. So if I do my pattern a little bit further, I should be able to figure out my next term, right? 32 times 2 is 64 over 27. And there's my next term, and this is geometric because it has a common ratio. Okay, so let's look at our last one here. And you might just notice it's doubling, kind of. I have positive, negative, positive, negative. So you want to be careful here. What's it actually multiplying by? 5 times what would give me a -10, and I'm going to have to go times -2. And then if I multiply by -2 again, -10 times -2, two negatives become positive, so I get my 20, and so on. So when you notice that it goes positive, negative, and those are alternating, you're going to have a common ratio that's a negative value. So just be aware of that if you're looking for it. We should be able to see the answer here pretty easily at what? It's going to be positive 80. All right. There we go.